Okay, Algebra 2. We're back, another lesson here. We're going to review some of the stuff that we are assigned after your LB quiz. Alright, so I'm just going to go through some problems that were on page 140. We'll pick out some of those, we'll kind of walk through that type of stuff, see what we know. For number 4, it talks about f of x equaling this negative x squared plus 4x plus 1. And then it asks a bunch of questions. Hey, what do we know about this? Well, first of all, I look at it and I know that it's a quadratic. Okay, so I know that this is going to be a parabola that's opening up or down. In this case, because this is negative in front, it's going to open down. So I know I have this type of a shape. Okay, I also know that the line of symmetry is that x equals the opposite of b over 2a. So in this case, that's the opposite of 4 over 2 times negative 1. That's x equaling negative 4 over negative 2. X is 2. So we know that x equals 2 is an axis of symmetry right there, which also tells me that the vertex is going to be, when x is 2, I can plug that in and find the value of f at 2. And this will be the opposite of 2 squared, plus 4 times 2, plus 1. So that's going to be 4 plus 1 is 5. Alright, so my vertex right here should be at 2, 5. That's x equals 2. And so opening down, we know those things. So I can do maybe this right there and say there's 1, 2, we're up at 5. I don't know. When we put in 0, we get 1. Okay, so at 0, it should go across at 1 right there. And we get a sketch of some of these things if we put our information in there. Okay, so we have a sketch of that for number 4. Let's skip ahead to number 8, and it says to solve by using factoring. So on number 8, it's asking us to take x squared plus 10x equals negative 21. But we want to solve this by factoring. So because I'm going to factor, I need it set equal to 0. So I want it to be x squared plus 10x plus 21 is 0. So that's x plus 7 and x plus 3. That equals 0. Well, the product of something is 0 happens when this factor, x plus 7, is 0. In other words, x is negative 7. Or when the other one is 0, and that's when x equals negative 3. So there I've showed the factoring. Not only is it the answer that's important, but what steps did I use to get there? Okay? Because it asks for that as well. Alright. So after we did that one, let's skip over here to your number, I think 11. Solve each equation. X squared plus 25 is 0. Okay? X squared plus 25 is 0. Now it doesn't give you any directions on how to solve. It just says to solve. So right away I'm going to say that x, well, what we could do is we could say, I'm going to say x squared equals negative 25. So x will be plus or minus the square root of negative 25. Remember that square root of a negative is the I, so this is plus or minus the square root of 25 times I, and then that's x plus or minus the square root of 5i. Right? And so, after here we can get to there fairly quickly. We don't need to show quite all those steps, but I wanted to make sure you could see with what I was doing exactly what was going on there. And then if I said x squared plus 12x equals negative 40, we're going to pick out another one here. And so we will say that for number 12, x squared plus 12x equals negative 40. Now I'm going to move that equal sign over a little bit because it doesn't say how to do this. I'm going to complete the square. So I'm going to take half of this term. I'm going to take 12 over 2, and I'm going to square that and add it to both sides. Now 12 over 2 is 6. 6 squared is 36. So we're going to add 36. And so we'll have x plus 6, that quantity squared, is going to be negative 4. Oh, nice. So how do I finish solving this? Well, we just square root both sides, and x plus 6 is plus or minus 2i. The square root of 4 is 2. It was negative, so it's the I part. And then we subtract the 6, so x equals negative 6, plus or minus 2i. Right? So we have that case right there for 12. For 13, write this in vertex form, and then identify its vertex. So for 13, a very similar problem would be to use completing the square again. What do we have there? Oh, minus 4x plus 9. So I'm going to go with the minus 4x plus 9. Oh, better leave some space in there. And then we'll go ahead and take half of this and square it. So we'll have negative 2 squared. But I'll be adding that. It'll be positive 4. So I'm going to sit on the same side and I'm going to subtract 4. See, here the result is adding 4. There the result is subtracting 4. Haven't changed it. But that will leave me with f of x equals x squared minus 4x plus 4. And 9 minus 4 is plus 5. And notice these three terms are a square of x minus 2, the quantity squared, plus 5. So there's vertex form. And what does that mean the vertex is? This will be the x, because that is subtraction. The form, so that this has to be x minus h plus k. We have a subtraction sign, we have an addition sign. That means the vertex is at the point 2, 5. So that's the other part that we know. Okay? That vertex is at 2, 5. All right, number 18. Graph the inequality. Y is less than x squared. Okay. Y is less than x squared minus, what is it, 4x? 3x minus 4. Okay, well, to graph this inequality, we want to graph the equality. We want to think of this as y equals x squared minus 3x minus 4. These three terms over here, this is a quadratic. That's, a parabola. So if I can go graph that, then I can worry about this greater than or less than by checking points and regions. So what I'm going to do is I'm going to say, do you know where x squared minus 3x minus 4 is? And that would be, well, what do we know about it? It's in center, so x equals the opposite of b over 2a would be my axis of symmetry. Therefore, in this case, that is going to be 3 over 2 times 1. So x equals 3/2, or 1.5, is going to be my line of symmetry. And if I put 3/2 in there, then we say our y value at 3/2 squared minus 3 times 3/2 minus 4 turns out to be 9/4. And this will be minus 9/2 minus 4. Okay, so multiply by 2 over 2, we get 18. So we get negative 9 18/4 here. Okay, and so we get negative 9/4. And then we want to subtract 16/4. So y equals negative 25/4. Okay, that's negative 6 1/4. And I say that because now the next thing I want to do is I want to be able to go ahead and graph that. And so we'll check this out on here. And we'll go over, let's see, right through 1.5. So we're going to go over here 1. We're going to go over here 2. There's 1.5, 3, 4, 5. And I need to go down 6 1/4, right? So 1, 2, 3, 4, 5, 6, 7. We go down 6 1/4, so we get to there and there. This parabola will open up, so I'll have something here. Let's see, I don't know what those are, but if I put in 0, I get negative 4. So that'll be right there. And so if I go 1.5 to the right, we're at negative 4. And so we get something here. Now, the problem is, I just graphed the equality. Now I need to figure out this inequality part. Do I need more ink or less ink when I graph that? And because it's strictly less than, I need less ink. So I need this to be dashed. So I'll go back and make that a dashed border. And then I need to check some points. Well, the easiest thing for me to do, there's going to be two regions that are true and false. I'm going to check this point 2, 0, which I think is, we're sure that 2, 0 is inside that curve. I'm going to check it for truth. The y value is 0, so my question becomes, does 0, is it less than 2 squared, 4, minus 3 times 2 is 6, minus 4. Let's see. 4 minus 4 is 0, that's negative 6. Is 0 less than negative 6? And the answer is that a true or a false statement? False. 0 is not less than negative 6. 0 is more than that. So that point does not get to be part of the shaded region. Therefore, I know that I'm going to be shading all of the things that are down here and below. Okay? So we have all of that stuff that's down there. Right? Then when we say to solve an inequality, like 19, so for 19 when we want to solve this inequality, I think I got enough room over here. Hopefully everybody can see this. The opposite of x squared plus 3x plus 5, and that is supposed to be greater than or equal to 7. Okay? Remember, for inequalities, for these quadratic inequalities, if they're not linear, we can't use our shortcuts. We're going to call this an equal sign, and we'll say when does negative x squared plus 3x subtract 7 minus 2 equals 0. Okay, well, if we can go ahead and factor this, great. If not, we need some way to come up with an answer there. And so I would suggest, let's, you can do a quick attempt at that. And yeah, I bet it's going to work. So the opposite of x, and then the positive x, I'll give you the negative there. And let's see, I'm going to go negative 2 and positive 1 there equals 0. Let's see what I get in the middle. That's negative x squared. That's positive 2x, positive 1x, minus 2. Yep, check. There it's factored. So here's the places where it's equal to 0. When the opposite of x plus 1 equals 0. When the opposite of x equals negative 1. When x equals 1. Or when x minus 2 equals 0, aka x equals 2. Now, these are the places where it's equal. Okay, let's check our regions. What does it say? 1 and 2? 1, 2. We're going to check a region. We're going to check 0. Go back to the original and check to see, what about 0? I get 0 plus 0 plus 5 is supposed to be greater than or equal to 7. Is 5 greater than or equal to 7? And the answer is no. All right? We could check 5. Opposite of 25 plus 15 plus 5, is that greater than or equal to 7? Well, that's 20. That's going to be negative 5. Is that greater than or equal to 7? And that answer is no. Check 1.5, all right, in here. Or actually, yeah, I'm going to go 3/2, and we're going to get the opposite of 9/4 plus 9/2 plus 5 is greater than or equal to 7. Well, okay, let's see here. That's 18, so this is going to be 18/4 plus 5. Is that greater than or equal to 7? Well, 18/4 is 4.5. 4.5 plus 5 is 9.5. Is that greater than or equal to 7? And the answer is yes. And we think that's that way for quadratics, because notice we're either going to be, usually for quadratics, unless it just does a touch and go, we're going to be either true in the middle and not on the outside too, or we'll be true on the two outside and not in the middle. Unless we get a touch and go, we might be true on all of them or false on all of them. Okay? So no, yes, and no. What does that mean our solution is? It means it goes between 1 and 2. 1 is, again, more ink here, less than or equal to x, which is less than or equal to 2. It's that region here, 1, between 1, including 1, and up to 2, and including 2. Okay? And that's how we show that answer, that 1 is less than or equal to x, which is less than or equal to 2. Okay? Let's solve that inequality showing algebra, and let's see. What is the last one in here? Oh yeah, let's do 1 minus 8, oh, okay. Yeah, I'll just do one more, I guess, sure. No, let's not do that one. Let's do number 24. 6 minus 2i, and 2 minus 2i. All right, let's go ahead and multiply those two things together here. And what we end up with is, got the right thing there, 6 times 2 is 12, minus 12i, minus 4i, minus is a positive, 4i squared. I squared is negative 1, so that's 12 minus 4, and I got a minus 12i and a minus 4i to be a grand total of 12 minus 16i in standard form. So there's some of the problems from that chapter test. Hopefully that helps you with your review, and good luck on the rest of the work.